Hello. I know that you are all very busy and immersed in the content that you are studying now for this semester and that's required of your courses. My name is Melissa Back, and I do feel like I would be a little bit remiss if I did not actually do a special lecture and information session on this pandemic. I want to give you just briefly my background. I am a licensed clinical microbiologist. I worked for 15 years at the University of Virginia in epidemiology and pathology, so this is actually my specialization. My undergrad, I was a generalist in diagnostic medicine and then went on to actually become licensed as a specialist in microbiology. So I do feel like I have a background in this, and I wanted to just share some information. Pandemics in the modern world, and this is including the one that we are right now in. We knew in epidemiology and pathology, we've known that it wasn't a matter of if there would be another pandemic after the very serious one that most of you all have heard about, the 1918 Spanish influenza. It was just going to be when they happen. They will happen. We live in a microbial world. We actually, our microorganisms are allowing us to live, and we've evolved with them here. But we do understand that occasionally there is this perfect parasite that comes along that can do serious damage to species and actually decrease their numbers tremendously. So in infectious diseases and epidemiology, the Centers for Disease Control for decades has been aware that there would be another pandemic like the one of 1918 that was so devastating to the human population. So we've been looking for them, and we are on alert for them, the Centers of Disease Control and the World Health Organization. So these are organizations that absolutely have been the first line of defense and alert for us, and so these organizations we certainly want to support. I want to give you a little bit of history about really the Spanish influenza. This picture that you're seeing here is actually of my grandmother and her brother, my great uncle Elijah, my grandmother Mattie Toombs, who lived in Saxe, Virginia. This picture was taken when she has on an egg apron. I don't know if you all can see that, and she's holding an egg in her hand. And some stranger had driven by their little farm in Saxe, Virginia, a photographer, and asked could he take their picture. And then this picture ended up being in a magazine, and so they were wondering, why would he want to take this picture of us? She had put a guana sack around her brother's shoulders because it had started to drizzle, and the looks on their faces are kind of funny because they're imagining like, what would this person want a photograph of us for? But anyway, Big Mama was a very special woman, my grandmother. She in 1918 she had a daughter that was 3 years old named Mary William. And it was her only child at the time, my grandmother. And she talked about Mary William quite often. But in 1918, in the October of that year, the Spanish influenza actually came through Charlotte County and was crossing the nation, actually in its first wave. And when it did, my grandfather, Big Daddy, we called him Big Daddy, and Mary William both succumbed to the illness, and they were very ill. Neighbors in Saxe, Virginia, a very rural area, would come to the yard, not into the yard, but far enough away to yell and ask her, did she need anything? Because they knew that Big Daddy and Mary William were both sick. On the third day, Big Daddy was in a coma, and Mary William died. So Big Mama had to yell to her neighbor that she needed a little casket, a little box for Mary William. And she cleaned her and dressed her and put her in the little box, and the next morning the box was gone. And the neighbor buried Mary William for Big Mama. Big Mama my mother was born right after that. My mother was the next daughter that was born to Big Mama, and she went on to have 13 other children. 4 children died of infectious diseases. Mary William was the first that died of the Spanish influenza, and then she had 2 that died from diphtheria and 1 from pertussis, which is what people call whooping cough. 10 children lived to be adult age. And Big Mama was always so thankful for that, because during that time, and even in my mother's own time, it was approximately a 50-50 chance your child would get out of infancy and make it to 5 years old. A 50-50 chance. I want you to get your heads around that. The reason that we can't imagine that now, even though that was not very long ago, not at all. Many of us remember prior to vaccines. The reason that we can't get our heads around that now is because of science and the discovery of vaccines. And then the widespread use of vaccines. That's the only reason that we don't have that still happening today. So a 50-50 chance before vaccines. Now, many of you are thinking, well, some people are not getting vaccinated now, but enough people are getting vaccinated for diphtheria, pertussis, measles, mumps, rubella, polio, chickenpox, all of these illnesses, that there is enough herd immunity at present, today, as long as we can keep that, that we don't see those types of deaths. Immunizations have absolutely, just in our country, saved millions upon millions of lives and changed even the social fabric that we live in today. Actually, even with the pandemic and the devastation that this is causing, we understand that there's really never been a better time to be alive as a human being as it is today on this planet. And the reason for that is because of modern medicine. Now, the influenza of 1918, it was estimated that 50 million deaths occurred, and this was at a time when the world's population of humans was less than a third of what it is today. Population doubling rates have really accelerated. So, this was at the time, there were 50 million deaths with less than a third of the population that was present. So when we think about mortality versus morbidity, mortality rates of illnesses are the number of deaths that you expect of people who get sick. So that's what's meant by mortality rates, how many people you expect that get ill will die from the disease. And morbidity rates are going to be the numbers of people that you expect to actually be ill. We need to be concerned about both of those for every single type of infectious disease, because it isn't just mortality rates that you have to worry about, though that is obviously of concern, how many people are expected to die, but the morbidity rates are also very important, because that's going to end up affecting hospitalizations and health care and economics and so many different social factors. So that's also very, very important to think about. Some more recent epidemics, big pandemics. An epidemic is an increase in number of infections in a small area, in a particular location. A pandemic means that there is this infection explosion around the world. So it's gone around the world. There have been other pandemics than the one of more than 100 years ago. There has also been, in 1957, the avian flu, in 1968, the Hong Kong flu, and 2009, the swine flu. So there have been other pandemics that have occurred, but the CDC and the World Health Organization and other institutions that were looking for them isolated them and quarantined them down. So they were a little bit more controllable at the time. So some of you may not have even heard of these, but they definitely were out there, and these were ones that were particularly controlled. So as far as their names go, oftentimes, and maybe you've heard of COVID-19 as being called the Wuhan virus, coronavirus, but if we think about this Spanish influenza, it was called that, and it did not originate in Spain. It's actually thought that it originated in the United States. So most evidence supports that that particular one that was incredibly devastating originated in the United States. So pandemics, we've had, influenza, we've had polio pandemics. Again, thankfully, most of you don't remember these types of outbreaks, but I remember a polio outbreak that happened in Charlotte County when I was a very small child, where our high school gymnasium was turned into an iron lung facility, and iron lungs were brought in, and the death rates were horrific. And my mother and father had huge concerns that their 8 children, I have 7 brothers and sisters, that we would succumb to these illnesses that are now very much controlled because of immunizations. We know that the human immunodeficiency virus that can lead to AIDS has also been something that we've been living with. Again, for a very long time. In the early 80s in the United States, this became prominent, and then by the 2000s, with science and with the the things that we had come to understand about how to prevent it and how to treat it and how it was spread. Epidemiology is what that means. We are now able to, many people with HIV positive status can actually live a normal lifespan now. Not all, but many can with the proper treatment and care. So that this pandemic we're in isn't the first. It won't be the last. But what we need to do as a public health situation is to understand what is going on with pandemics and how they affect more than just the individuals affected, how they absolutely affect society and as a whole, and all the different things that it affects in the society as a whole. So these are some of the things I want to talk about, and I don't want to get too bogged down in some of that. But we understand that this particular pandemic is caused from a coronavirus. So coronaviruses are not new. They're actually the first SARS coronavirus 1, SARS, Severe Acute Respiratory Syndrome, coronavirus 1, was back in 2002 to 2003 and had a 10% mortality rate. So that actually was much more aggressive as far as like its lethality. In 2012, MERS, the Middle Eastern Respiratory Syndrome, thankfully, this was quarantined down because it had a 35% mortality rate. So this was actually more of an epidemic because it was isolated and shut down. Some of the European countries and Asian countries have handled this current pandemic much better, unfortunately, than the United States. Actually, we aren't even close to handling it as well as they did. But this is because in the last 2 decades, they very much dealt with these two. They understood the seriousness. They understood how many different things were affected, not just people dying that they knew, but how it could affect economies, how it could affect so many different things in the social fabric, that they handled this one better than we did, and they have a much lower mortality rate than we did. This particular one, the Wuhan, sometimes people call it Wuhan virus, but this SARS-CoV-2 virus, also known as COVID-19, this one we're going to take a look at, and we're going to look at some of the specifics about this. But again, we understand that these coronaviruses are not new to the human species, and they are evolving. Some viruses evolve more rapidly than others. Some are very stable in their structure. And when I talk about structure, I'm literally talking about what they look like. And if they're very stable and they don't change their outfits very much, then in the human population, once someone has had a vaccine, hopefully a vaccine, rather than having the illness, then there is this immunity protection that the person will build in the form of an antibody response. So we do understand that some are very stable, so we don't get them more than once. So, for example, measles, mumps, rubella, chickenpox, those are the types of things, those viruses that you don't get more than once. And if you had a vaccine, you don't get them at all. Now, there are other viruses whose outfits change. They evolve. And some evolve more rapidly than others. So you all have been hearing, you've always known that every year you have to get an influenza vaccine. And that's because the influenza virus changes its outfit slightly each year. And as it's changing its outfit, it means that your antibodies that you made last year might not be as effective this year or effective at all this year because the virus evolved. What we know about coronaviruses is that they rapidly evolve, especially this particular SARS-CoV-2. It's rapidly evolving. We have seen quite a few variants, and as long as it stays in the population, the more individuals that actually have this virus, the more of a chance it has to evolve. And each time it evolves, the vaccine that we have today becomes less effective. Still it's showing some effectiveness, but less effective. So I want you to keep that in mind as we are moving on, and I am going to kind of go along. You would have these slides that you could go back to and absolutely, take a look at. If you have any questions about this, please feel free to email me as you are researching this. But I do want you to be given facts instead of fiction and fear, So I just want you to make sure you understand that we live in a microbial world. This is not some country or person's fault that this happened. This is natural. These are species that actually, many of these that cause infection in humans, we understand jump species. From this particular coronavirus, we know that it was isolated in bats, and it's been studied because we knew that this was a particular coronavirus that had a clear and immediate threat to humans. So this has been being studied. I also want you to know that, and when we get to the vaccines, I'll talk a little bit about this, but nothing has been rushed as far as the science goes, as far as these vaccines go. Messenger RNA vaccines, though now have been used in, at this point, for this pandemic, billions of people around the world these vaccines have been studied since the 70s. So nothing was new, nothing was rushed, and nothing was new. What was rushed when we think about the warp speed of getting these immunizations was the red tape was pushed aside and funding was given. And thank goodness for that. But the science of safety for vaccines and efficacy and trials, none of that was rushed. And no shortcuts were taken from the typical research and development that happens with any of the prior immunizations and vaccines. Again, when we think about, this is the coronavirus, but when we think about any viruses and vaccines, they are actually targeting the outfits. And when you think about these spike proteins that you hear about a lot in the news, this is what they're talking about. They're literally talking about the unique outfits that these have, and what you try for is to get the body's immune system to make a perfectly complemented antibody that would specifically fight against that particular spike protein that is found on these viruses. And again, nothing of that is really new in immunology and in our vaccine research. So when we think about the viral spread for this particular coronavirus, it is respiratory borne. We know that it is. And we know that this newest variant, Omicron, is very highly contagious. So they are typically spread in these water droplets when someone is speaking, someone is sneezing or coughing. And so we do understand that this is a respiratory-borne virus, which for any respiratory-borne virus, these are the most easily transmitted between humans. So what we want to do is, we know indirect is of less concern. In the beginning, when we didn't understand, we were really careful about what we were touching, doorknobs, and we still need to wash our hands. Washing your hands is one of the most effective ways to actually reduce the spread of disease, all diseases. Hand washing, vital. So we still want to be careful and make sure that we're doing that. But we also want to stop certain practices like handshaking and shaking hands and that sort of thing. And that should be just something going forward that we do, because we are living in very dense populated areas. So we do understand that these are the areas most at risk as far as the transmission goes. How it enters, typically it's going to enter through the upper respiratory airways, and so we know that, oral and esophageal cells, and we know that this particular virus has a real affinity for what is called the ACE2 receptors. So the thing about that is we don't just have respiratory cells that have the ACE2 receptors, they are also in our heart muscle, they are in our GI system, the blood-brain barrier, and multiple organ systems that we will see. So again, this adds to the pathogenicity of this particular virus and our understanding of how this virus, people think about this virus as being a respiratory virus and that people are going to have trouble breathing. But this is really not the case. This particular virus is really more accurately referred to as a vascular virus, and you have blood vessels to every organ system, including your blood-brain barrier. But this is why people are also dying of this virus from strokes, from heart attacks, from kidney failure, from GI issues. So this adds to the pathogenicity of this particular virus. Because it attacks the blood vessels, these ACE receptors in blood vessels, in the lungs, it causes fluid to leak into the lungs, and it causes that fluid to be taken up by a gel-like substance that makes it incredibly hard for you to move air in and out of the lungs. Because of that, we found out very early on in epidemiology that really putting somebody on a ventilator wasn't really doing much good, because even if you're on a ventilator, you can't breathe through gel. So we've learned a lot since encountering this particular virus and how it actually not only enters into the body, but what happens once it's inside the body. So I don't really want to, we get into this a little bit more in some of my coursework, but there's a lot of different things going on in this, and it ends up leading to multi-organ failure. We need to also understand that the incubation time and rate of this being so long has also contributed to the devastation of how it spreads, because people are spreading it that don't know they have it. So this is why masks are so important. And when I say mask, I mean effective masks. So wearing masks that we know actually are going to work, not just a little handkerchief or whatever some people are trying to do. And actually, there's some people not wearing it. So the crucial thing is that some people are infectious typically a couple of days before they ever have symptoms. So you should be wearing a mask all the time. And then you can be infectious a few days even after symptoms. And some people are asymptomatic. So again, washing hands, wearing masks, keeping a slight distance, all of those things are important for helping to prevent the spread of the disease. So, and again, you can see some of the numbers here. Most of this information was recently obtained in I think it was August 2021. So most of this information, and some of it is even more recent than that with the Omicron variants. So I let you go through these as you would like to, but we do understand that these are some of the manifestations of the disease, and it can be really difficult for the patients that are being seen in critical care in hospitals. And we are at this point overrunning our hospitals. When you hear that the health system is in a crucial, critical state and it's at a risk of collapse, I want you to really understand what that means. Because there's so many people with this disease, and it manifests itself in a very serious kind of way, that people seek support through doctor's offices, emergency rooms, and eventually sometimes have to be hospitalized, that this has overwhelmed our healthcare system in this country. Never before have we had the number of patients that are needing to be seen across the board for this. And when I say that our health system is in crisis and at risk of collapse, what that means is that the people that are in the hospital, and I know this very well because I still have many of my dear friends are working pathology, and even my own, I have a son who is working critical care. Many of the things that go on in the hospital that have for decades had certain protocols, certain protocols and certain time limitations for happening in a hospital are now being extended because there's no staffing and they're so overwhelmed with patients. So things that should have taken 15, 20 minutes turnaround are now taking hours. And what that equates to is loss of life, not just for people that are coronavirus positive, but for all the patients in the hospitals. Everything is taking longer to get done. So when you have something that is an acute care or critical care situation, that extra length of time, minutes, can make a difference. There is nothing more devastating to a human body than infectious diseases. There's nothing that no metabolic disorders like diabetes or anything metabolic that can take you out of this world in a matter of minutes or hours than these infectious diseases. So now we're having people who are in the hospital for trauma, car accidents, whatever, or people who have other conditions like hypertension that's leading to respiratory compromise that have nothing to do with coronavirus. But because staffing crisis and because of critical care attention taking so much longer, those deaths are increasing. So I also need for you to understand that since the advent of these vaccines, and there are multiple vaccines that we see, since the advent of these vaccines, most of these deaths have been preventable. The people that are dying now, and the people that are in the hospitals now, by a huge margin, are the unvaccinated. In this country, vaccines are offered to every person, free actually, and for the most part, not all, but for the most part, they prevent you from getting so ill from this that you would have to seek in-house care. So you would be, by doing a public health service, it has nothing to do with individual rights. It has to do with public health responsibility and service. By being fully vaccinated, you are actually doing such a service to try to support not just our healthcare system that is trying to take care of all people who need supportive care, not just the coronavirus patients, but also the economy, education, and so many different areas with that. Now, some people actually do think that the vaccines are unsafe. This is, again, at this point in time, billions across the world, billions of people have been immunized. And there's no such thing as a complete risk-free invasive procedure. Whether you are having a CT scan or whatever you may be having, there's no such thing, including vaccines. But what we do know from the billions of people that have been vaccinated, the risk is so minute compared to the risk factors of actually having this virus. And that's for anyone of any age. Long-term COVID symptoms now are of tremendous concern, not just for people older or people immunocompromised, but for younger people as well. So now I'm not talking about the people that you can expect to die. That's the mortality rate. You will lose people. And for the large part now, this has become unnecessary because of vaccines. But also the people that will be sick. And what we know now for long-term COVID situations is that we are seeing people who are having cardiac concerns, GI concerns, blood-brain barrier concerns of the nervous system. So we are seeing those ongoing complications for people who actually have the disease. What vaccines do is can not only prevent illness, in some cases, not 100%, no vaccines are 100%, they've never claimed to be, but that it can prevent severity of disease and then can prevent some of these long-term consequences of actually having active disease. You will unfortunately see, and it's really easy to see when we see the caseloads, and this was as of August of fall last year, caseloads being so much higher in certain states, and that actually has every single thing to do with leadership and politics and unfortunately misinformation. So you can see where the most maybe misinformation and absolutely illness and loss of life has actually occurred. And it's really an easy thing to see just with the simple numbers of this. So how do we control it as a public health responsibility of each individual? Is we test, we isolate, we do contact tracing, we quarantine, we do all of these things, and these can help us. There's different types of testing. You hear about PCR versus antigen testing. So, and then also antibody testing to see if you've actually been exposed and you have the antibodies. You wouldn't have made the antibodies unless you had actually been exposed. So this is called an indirect serology test, where these two are direct serology tests. You will often hear about false negatives and false positives. Again, that's the case with any types of serology testing. But if the testing's done correctly, and if it's performed correctly, then you can have very much confidence in what is going on. You've also heard a lot about herd immunity. And when you hear about herd immunity, this means that there's enough people in the population that's protected. It would protect the few individuals that are surrounded by the ones protected. It would protect them from getting the disease. So for herd immunity, we absolutely need to have a certain percent of our population immunized, vaccinated, and or with naturally occurring antibodies. But what we know is we have the ability to actually do this, if we could get enough people immunized, that this would be a potential possibility. The thing about this coronavirus, that it evolves so rapidly, and I'll let you see some of these and you can look through these. It evolves so rapidly that we do absolutely know that the variants are going to continue, because there are not enough people that are protected to get us to herd immunity. And it would have to be more than just our country. We would have to really do enough immunizations throughout the world. And if you think to yourself, well, how could we ever do that? How could we ever accomplish that? We've done it before. We've actually worldwide did an immunization project in the 1970s for smallpox, which was a devastating illness with an incredibly high mortality rate. And we eradicated it in the 1970s. Through immunization, smallpox is not something now that people have to think about. And lest you forget, please Google smallpox, the illness, and see how devastating that has been in human history before the 1970s. So we can do a worldwide immunization. We've done it before. We've gotten this close to eradicating polio virus from the population. There have been several times that it has been down to just 1 or 2 countries. And so we've almost eradicated that through worldwide immunization. And we can do this one as well. There may remain some variants, because we do understand that this is a rapidly evolving virus. But even with the rapidly evolving virus, we do know that with proper epidemiology and surveillance, we can isolate this if we can get enough herd immunity and enough immunization actually happening. So I've covered so many things, and I've tried to do them in a sort of a short order here. But you do understand that there have actually been a lot of variants that are occurring right now. This Omicron is the surge that we're actually seeing, is probably the most. And we do know that we just need to get everyone realizing that each individual has a responsibility as far as public health is concerned. And to get a handle on this is what it's going to take. And I feel hopeful that it can happen. I have added a few other slides that I thought of interest to you, just talking about what the difference between efficacy and even effectiveness. I know they're linked oftentimes, but there's a difference between the two. And then also safety, and then a visual for you for herd immunity and what it really means. If you have enough people that are immunized in a population, the few that either can't get immunized because of their overall medical health or reasoning, they can't get immunized. Maybe they're too immunocompromised or whatever to get immunized. But anyone that can should get it, because then you can actually, it can be effective. Herd immunity can be effective. So anyway, these are some of the resources that I have used and some of the slides that I've taken from CDC and also from some of the textbook information. I hope that this has helped. There's so much misinformation, and it seems like, there's a saying that a lie will travel the globe twice while the truth is putting on its shoes. And that actually today, maybe because of social media and because of whatever, that seems to be really true. And I think it's also part of human nature that people will, if they hear something that's fearful, they will hold on to that. Even if it seems sort of far-fetched or whatever, they'll hold on to that much more readily than they will hold on to scientific facts, which can sometimes be kind of dry. So I would just encourage you to not not believe anything that you see on social medias, and then to also be very, very careful where you get information about something as important as what is going on right now. Some myths that have come have been that the vaccines change your DNA. No, they do not. Or that they cause infertility. No, they do not. Or that they're more dangerous to your cardiovascular health or whatever than the virus. That is absolutely not true. So there's just so many myths out there, and when I say myths, I mean misinformation and falsehoods. So please, if you have any questions or concerns, I would hope that you would email me. You're welcome to at melissa.back@southside.edu. And I hope that you stay well and take care.